Here we go with the problems. All right, so I'm gonna have my PDF pulled up on the side, but I think it's best if you guys also follow along with your own PDF. But that's up to you, of course. Or if you want to print it out, I think that's actually even easier personally. But that's up to you. Maybe you don't have a printer, so I don't know. Okay, anyways, let's get started with the problems. I'm gonna do it this way. I'm gonna look at the problem. I'm gonna type out what we should be doing here, and then I'm gonna just do it in the calculator on the bottom. All right. So the first one, it's the type 1 problem, calculate the amount of simple interest. So here's what we should be using. We're using the simple interest formula. I is equal to PRT. That's it. And here, so in this first question, what's helpful is to identify what is each individual piece. I'm trying to figure out I, so that's a piece I don't know. That's how we always typically will have it. We'll have the thing on the left that we don't know, and we figure out the things that we do know. So 10,000 is the principal. The rate is let's say it's 2.25%. But as a decimal, first of all, that's 2.25%, right? But remember what we did with changing how do we from percentage to decimal, we have to move it over twice. So that's once, twice, 0.0225 would be the rate for 5 years, so times 5. Okay, what I'm going to use is the Desmos scientific calculator. Same one I recommended to you before. You can use this one as well online if you'd like to. So 10,000 times, or I can even write like this, times 0.0225 times 5 equals 1,125. So this is your answer right here. That's the interest. This is how much you would pay in interest over 5 years at 2.25%. Simple interest. Okay, number 2, same thing. We're just going to modify this slightly. We have 100,000 this time, right? At 0.3%, 0.3%. So okay, let's write this out first. 0.3%. Then I move that over twice, so once, twice. That's a decimal. 0.003 for 7 years, like that. It's going to be 100,000. The right number of zeros? Yeah, okay. Times 0.003, 0.3% times 7. And the answer is 2,100. So a very small percentage, but a large principal, so we end up with $2,100. This is the answer for number 2. Okay, number 3. Find the future value using the future value formula. And there are different kinds of future value formulas, right? Let's look at problem number 3 first. This one's using simple interest for 3 years. So we have $1,000. Okay, well, let's write the formula first. Formula is A is equal to P times 1 plus RT. Right? We don't know A, that's what we're trying to figure out. Okay, so we don't know A. So what we do is we fill in the parts that we do know, $1,000. And the rate is 3.75%. So that's 0.0375 as a decimal. Multiplied by 3 years. 3 years right there. Right, so this is a time. So let me write it like this actually. Times like that. Okay, so when I plug it into the calculator, it's gonna look like this. 1,000, 1 plus 0.0375 times 3. And I get 1,112.5. So $1,112.50. And this is including the original $1,000. Okay. You might have done this a little bit differently. You could have also just found the interest by itself and then added it on. That would have been fine as well. Okay, number 4. This time it says compounded monthly. Okay, so this time what I'm going to do, and this is maybe a good recommendation for you in general, I'm going to just start by writing out my formula and then write out what our individual letters are. This is going to be a good practice when we get more and more complicated. So let's start doing that from now on. First of all, what is the formula? It's A is equal to P times 1 plus R over N. Okay, actually, I'm going to change to my math mode so I can type this better. A is equal to P times 1 plus R over N raised to the NT. Right? So I'm just going to fill in what my individual values are. But before that, I'm just going to make a note of what everything is. I'm trying to figure out A. I'm going to write what P is first. P is $2,000. Yeah. And then what is R? R is 5.5%. So as a decimal, 0.055. Okay. N is the number of times compounded in 1 year. So compounded monthly means 12. And then T is the number of years. So T is, in this case, 7 years. So 7 like this. Okay. So I have all my variables, and I'm just going to fill them into this formula. I'm going to fill them in down here as I put it into the calculator. Oh, you know what? Let me type it once first, because I think this could get confusing. So I'm going to type it on the right here. This is 2,000, 1 plus 0.055 divided by 0.055 divided by 12 raised to the nt. 12 times 7. Like that. Okay, there we go. Just had very enough space to fit. All right, so this is, like normally when we're doing this kind of questions, I would ask you to write this part out. But so I think you should get used to being able to do this. I'm not sure exactly yet how we're going to format the test. I'm thinking maybe actually to do a paper pencil test this time, and you just take a picture of the answer. So we should get comfortable writing something out like this. That way, even if you mess up the calculator part, I can at least give you some partial credit for that. Okay, so how would you type this in? This is a critical part when we're typing in an answer to a calculator. We have to pay attention closely to the order of operations. So here's how I type this out. 2,000 times 1 plus 0.055 divided by 12. Well, the nice thing about this calculator is it actually writes it out so that it looks like how we're supposed to see it. So, and finally, the caret button to get to decimals. So I just press the shift 6, that's the little caret. That's to give you to the exponents, I mean. Then 12 times 7. Okay, so you notice what happens though, if I type 12 times 7, because of the order of operations, it takes the exponent and then multiplies the result times 7. So what you need to do is whenever you have an exponent, include it in parentheses. Parentheses 12 times 7, and then close the parentheses like that. So keep your exponents in parentheses. It's just the general rule of thumb. Okay, so that equals to $2,936.64. So that's the answer here. 5.5%, 7 years. The interest turns out to be $936. So the end result is $2,936. Okay, the next question. Oh yeah, I was looking at the wrong side. Okay, so next one. This one's a little bit weird. When it says compounded daily, actually, for some reason, businesses use 360 instead of 365. So be aware of this when we do the calculation. We're actually going to use 360 instead of 365. Well, don't ask me why that is, because I actually don't have a good answer for you. You can probably Google search it and figure it out. Oh, actually, no, it's the same formula as last time. Compounded continuously. The only thing that's going to change, so our principal is still 2,000. Rate is still the same. T is still 7 years. The only thing that changed here is the compounding, and we're doing daily now. So instead of 12, we're going to go to 360. And again, not 365, just because, I don't know, they're peculiar like that. They use 360 instead of 365 for a year. So I'm going to replace the instances of n with 360 now. Instead of 12, it's going to be 360, like that. And I'm just going to do that. I'm going to just copy this previous equation, because it's really the same thing again. Only difference is replacing now with 360. Okay. 360. And you look, oh, it's almost actually the same, yeah? Whether I compound monthly or I compound daily, I only really gain $3 over the course of, no, less than $3 over the course of 7 years. So actually there's not much gain there. Okay, let's check the continuous now. So problem number 6. Problem number 6 is a bit different. This time it's continuous compounding for 20 years. So continuous compounding means it's going to be A is equal to PE to the RT. Right, so what are my variables? There's no n to speak of anymore, so I can ignore that. Principal this time is 13,000 at 7.5%, so it's going to be 0.075. Oh, excuse me. And then T is 20 years, so oops. T is 20 years. All right, so when I go to plug this in, it's going to look like this. 13,000 times E to the 0.075 times 20, just like that. Okay, how do we punch that into the calculator? Let's see. It's going to be 13,000 times E caret, and again, you want your exponent in parentheses, so 0.075 in parentheses times 20, like that. And you end up with 58,261 and 96 cents. So you always want to round these. By the way, I haven't talked about this, but whenever you answer these, you want to round to the nearest cents. Unless it tells you dollars, then you round to the nearest dollar. Okay, so this would be 64. This would have been 14 over here. This one we just did would have been 58,261 and 96 cents. Okay, that's number 6. All right, only 3 more to go. Okay, so number 7. This time we're trying to find the present value. In other words, how much should I put down now, or how much do I want to borrow? Am I borrowing in order to end up with a future value that's given to me? So this time we know A. So since I know A, then it doesn't make sense to use an equation that's going to solve for A, right? Here, let's see. Number 7, we want to achieve $10,000. So that's your A, your end result that you're getting. Yeah. In 3 years, so that means the T is going to be 3 years at 3.5% interest, simple interest. That means your rate is 0.035. Now, what is the formula we're using? I kind of did think backwards that time. What is the formula using? We're using the P is equal to, this time it's going to be the end result over, and then let's just check back our formula, 1 plus RT, right? 1 plus RT. We're using this guy right here. Simple interest present value formula, formula 5. Okay, so I'm just going to plug that in. Oh, let me plug in what that equals to. Numerically, that's 10,000 on the top. And the bottom, 1 plus 0.035 times 3. So that's what we're going to type in down here. 10,000 divided by 1 plus 0.035 times 3. And you get 9,049 and 77 cents. That's that one. Okay, number 8. We want to achieve $2,000 in 5 years, 2% compounded semi-annually. Okay, compounded interest this time. We're trying to achieve something again, so this time we know how much we want to end up with. I'm going to start by just writing the facts that I know. I know that I want to end up with $2,000. I know that the rate is 2%, so 0.02. I know that T is for the number of years, 5 years. There's one additional variable here, the number of compounds per year. Semi-annually, that means it's compounded twice a year, right? Semi-annual, 2 times a year. Semi meaning half, so every half year. So it's equal to 2. And then we're using this present value for compound interest. That's this guy right here. P is equal to A over parentheses 1 plus R over N to the NT. Then we just fill in our particular values. So that's going to be 2,000 on the top, and bottom 1 plus 0.02 divided by 2, and it was 2 raised to the 2 times 5 years. So 2 times 5. Like that. This is what I want to type in. All right, let's see how we type this in. Okay, so it's gonna be 2000. You know, right now this calculator makes things easy. But if you're doing like a handheld calculator, what you typically want to do is just include the denominator in its own set of parentheses. If you're doing it with a normal like handheld calculator. But this one makes things easy. I'm just going to do 1 plus 0.02 divided by 2. I still do need another set of parentheses though for this part before it's raised to that power, right? So just like that, raised to the, again, exponents in parentheses, so 2 times 5 like that. So this will be number 7 answer. I'm sorry, this is number 8. I forgot to change the number. This is number 8. Yeah, 2% semi-annually, $2,000. So this tells me I should invest $1,810.57 roughly in order to end up with that. If you want to be actually more accurate though, so if I want to make sure that I achieve $2,000, 57 cents is lower than what I really need. So you'd actually probably want to round up to 58 cents, right? To make sure that you achieve what you're looking for. And same thing would apply actually for number 7. If I write 77 cents, actually that's going to put me right below. But if I want to make sure that I hit the 10,000 mark, then you actually want to round this up, even though it doesn't round up because it's a 3, you want to round up to 78 cents just to make sure that you're going to hit that value. You want to achieve at least that number, right? Okay, last question. Last question. This time it's compounded continuously when I want to know present value, so that means use this formula. A over e to the RT. Like that. That's this guy right here. P is equal to A over e to the RT. So now there's no n to worry about. Let's see. In our question, we want to achieve $1 million. So A is $1 million. R is 8.75%, so 0.0875. And compounded continuously for 7 years. So this is 7 years. Okay, how much should I put in now so that I will end up with $1 million? Let's just fill in our values. That's going to be 1 million on top. The bottom is e to the 0.0875 times 7. Like that. Okay, so let's type this in now to our calculator. 1 million over e to the 0.0875. And again, exponents in parentheses, yeah. Times 7. And I get 541,994. Okay, not too bad. So if I invest $541,000, then I'll end up with $1 million at the end of 7 years. With this interest rate compounded continuously. Again, though, I want to make sure that I hit $1 million, so I should round up to $541,994.19 to make sure that I reach that value. Yeah. Okay, guys, that is it. We are done. So good luck with the questions. On the next class, I'll be answering questions, and we can go over this stuff again. Okay, shoots. Have a good one.